Games have always been used by humans because they're engaging, they provide social interaction, and they provide some sort of value of personal and group satisfaction. This is where I see games becoming immensely powerful. We can bring people who want to help towards super productive ways in which they mesh with their disparate expertises in such a way that we can solve these problems that we simply have no way of solving today.
Zoran Popovic is the director at the University of Washington's Center for Game Science. His team takes complex scientific questions and transforms them into games that average people can play and help solve.
Video game is an interactive experience that allows you to face and quickly resolve a particular challenge that you wouldn't necessarily see in real life.
The games that Zoran and his team build look like simple spatial puzzles. Imagine Tetris, but instead of aiming for a high score, winning players could help end some of the deadliest human diseases. For example, in the game Foldit, the colorful shapes and blocks players arrange look like many other games, but they actually represent the proteins that power living cells.
Proteins are the doers of our cells, of any living organism. So basically anything that needs to be done is done by proteins. You can imagine proteins as sort of a long necklace with a whole bunch of different things as beads on it. Foldit is a game that's predicting what this necklace would naturally form the shape into.
Scientists can take gamers' discoveries and bring them into labs to test them in physical space. At the Institute of Protein Design at the University of Washington, research scientist Brian Kepnick takes gamers' protein formulations and recreates them in actual test tubes. Modeling a scientific result first can help scientists get a jump on making sure they're effective in real-life applications. Zoran believes that it takes both humans and computers to crack the code for curing something as complex as, say, the HIV virus.
There's an HIV virus, has a number of proteins on the surface. And there were scientists for about 13, 14 years trying to figure out what is the shape of this outside protein, because if we knew what its shape was, we could figure out how to attack it and neutralize it. So we presented it to the Foldit community, and 2 weeks later, a brand new shape of this protein is proposed. 2 weeks later, confirmed in the laboratory. That's exactly what the shape was.
This discovery couldn't have been made by man or machine alone.
It's clear that computers are very good at some aspect of things. But when it comes to spatial reasoning, specifically looking at a whole bunch of different shapes and seeing exactly how they will best fit together, computers tend to be fairly bad at this. But a person can actually look at these two pieces and say, what if they were just like this?
With Foldit's success in helping decode HIV, Zoran's team has continued their work by creating games that tackle how aging neurons deteriorate, all of which has major implications for treating neurological diseases like dementia or Alzheimer's.
The question is, how can we as a society be more effective at actively working and seeing outcomes on actually resolving some of the things? It's kind of a meta game, if you will, right? It's a meta game of how to get the entire, as many people as possible engaged on problems that humanity cares the most about.